Hello, everybody, and welcome to another Mystery Box Function Challenge. In the purple mystery box, there is some mystery math, and your challenge is to figure out what it is. And today, because it's a Friday, that math is going to be particularly challenging. If you'd like to try this out, use the link in the description, put in as many numbers as you like, and when you think you have an idea, come on back and see if we get the same thing. All right, let us begin with a 0. Oh, so 0 gives us not a number, so that's some kind of error. Maybe this is a square root function that's been moved over, and so 0 becomes like a negative number. That could be. Let's put in a 1. We get a non-repeating decimal, so definitely could be square root function of some sort. Let's put in a negative 1. Oh, so far it's symmetrical across that y-axis, and negative numbers are working, so maybe this isn't a square root function. I guess with non-repeating decimals like this, I also would consider a possibly trig functions. Let's put in a 2. Okay, another non-repeating decimal. How about a 3? 3 is pretty close to 0. And a 4. Okay, and a 5. Oh, interesting. It's already starting to come back up. How about a 6? Huh. And let's try some of these negative numbers too. I might have a hunch about this one. Let's do negative 3.14. Let's go for an approximation of negative pi. So very, very close to 0. So I'm assuming pi and negative pi are going to be 0 here. We're close to 0 right there with 3. Let's go out further. So let's do negative 6.28. So an approximation for 2 pi. Yeah, and that's close to 0 as well. So this is a really odd one. There are a couple of strange things going on. I am thinking trig. In fact, it sort of starts to look like the sine function. Although, this is an odd one. So let's think about this. If we had sine, the sine would be, so the n coordinates here, if we put in 0, would be the 0.1 comma 0. So sine would be 0, but we get undefined at 0. There's a hole in the graph there for some reason. So I think it's more than just that, more than just the sine of x, clearly. But at pi and negative pi, we're getting very close to 0. At 2 pi, at negative 2 pi, we're basically 0. And those are places where sine would be 0. So I think sine has something to do with this. What would give us an error at 0? Well, if we put something in the denominator, that could do it. So if this is sine of x over something where you get 0 in the denominator, that would mess things up and make this undefined. Something else seems to be going on. I want to actually look closer in. So I'm going to erase these things for now because I want us to see closer in. Let's go, let's say 1/2. 1/2. And let's go 1/4. I went 1.4. Let's try it 1/4. Aha. So it's just getting closer and closer to 1. How about 1/10? Yeah, so it looks like a very smooth hill there, but it can't ever quite make it to that 0. And what happens as we go out a little bit further? So we've got 6 on there. Let's go 7 and 8. And the numbers are not showing up here because I'm way off the end of my chart. Well, actually, they're bunching up there, but it's hard to sort them out. But I really just wanted to see the shape. Yeah. So So this looks like, well, actually this looks like part of the cosine curve here, but I do think this is sine because of the values for pi and 2 pi. But it looks like it gets shallower and shallower. So the values that are coming out here are closer and closer to zero the further that we go out. It's pretty steep here, but then just shallower and shallower. So what could possibly be doing that? Well, when I saw that zero was undefined, I thought, well, what if x is in the denominator? And I think this is a good candidate. Let's think about what would happen as we go out, though. So let's think about the sine of, 2 pi. So the sine of 2 pi over 2 pi. Well, 2 pi is going to be 0. So that's going to be 0. And that makes sense. That's what we're getting at 2 pi. But what about something really close to that? So what that would mean, if you're really close to 2 pi, you might have some very small number up here, 0.0001 if you're very close to 2 pi, and then still a 2 pi down on the bottom. So that is going to be very, very close to 0. And in fact, the bigger these numbers get on the bottom, the closer to 0 that's going to be. So as you stretch out to bigger and bigger magnitude numbers, these fractions are going to get smaller and smaller. And that's why I think you're seeing that sort of shallowing out of the waveform as we go along. Yeah, that's my best guess, and I don't know that we're going to find any magic numbers to test here other than the ones we've seen already. So I'm just going to go ahead and reveal this. Yeah, okay, so there it is. So f of x equals the sine of x over x. Let's graph this one. It's pretty cool looking. Yeah, and there it is. So you don't see the hole in the graph at 0 because we have all the points really close to 0, but it's not defined there at 0. And then you get that symmetrical wave that kind of flattens out as it goes towards infinity. Well, that was an interesting one. I think this was the toughest one yet. Did you think trig? I think if you got that far, you're doing pretty well. Let me know. Thanks, everybody.